Alright, now let's quickly write the C++ implementation for the algorithm that we have discussed previously. So here I have defined the function declaration also, right, which is basically taking a vector of integers in the array variable. So here first let me just read the length of the array that we have got so that we can use it wherever we want as per our requirement. For example, whatever the array that we have got is sorted but not at all rotated. That means all the values are sorted and remain in the ascending order. In that case, to find the smallest value, what I want to do is I want to compare the value at 0th index. If at all the value at 0th index is less than the last value we have, which is nothing but the value at length minus 1th index. If that is the case, the array is sorted and not even rotated. In that case, we will simply return the smallest value, which is nothing but the value at 0th index. Okay, so this is to handle the scenario where the array is not at all rotated. Let's say to handle the other scenarios where the array is rotated, in this case what we will do, we will apply the binary searching technique. So for binary searching technique, let me just define helper variables start and end. End will be pointing to last index and start will be pointing to first index, and along with that I will also be defining the middle. Now here what I will do is I will run a loop as long as start is less than end. We will calculate the middle. That middle is nothing but like in any other binary searching problem that we have solved, it will be start plus end divided by 2. Once we calculate the middle, the next comparison that we do is whatever the value we have at the middle index, if at all if it is greater than the value we have at the end index. Here we have the value at the middle index and we have the value at the end index. Now we are basically comparing these two. If at all the middle value is greater than the end value, since the array is sorted and rotated, the smaller value will always be lying on the right part because the middle value is greater than the last value we have. That's why to continue the search on the right part, we will simply update start with middle plus 1. If this is not the case, that means the smallest value could be middle or any value on the left of the array. To continue the search here, end we will simply update it with middle itself. Remember here the other scenario is since the first condition has not matched, the smaller value could be whatever the value we have at the middle or any value on the left of the middle. That's why here we have updated the end with middle. Once we complete the searching in all the possible ranges, in the end we will simply return the value we have at the start index, which basically holds the smallest value. Okay, so that is the implementation of finding the minimum value using binary searching technique in a sorted rotated array. Okay, so simple one, nothing to worry here. So if you look at the values that I have passed in the array are basically 4, 5, 6, 2, 3. Technically if the array has not at all rotated, the values will look something like this, right? 2, 3, 4, 5, 6, which is sorted in the ascending order. Now the array is rotated twice, that's why the input will be 4, 5, 6, 2, 3. In this array, the smallest value is 2, right? So if I run this program right now, the expected output is 2. Okay, so let me just expand this. Look at here, the output is 2, which is the smallest value. Let's just say I have deleted this 2. Now in this sorted rotated array, the output is 3, right? So if I run this code right now, the output should be 3, which is what we have got. To test another scenario, let's just modify this to 8 itself. So the entire array is sorted in ascending order and not at all rotated. So the output should be 4 here because the smallest value is 4. So if I run this right now, the output should be 4, which is what we have got as well. Okay, so that is how we find the minimum value in a sorted and rotated array. If at all if you want to validate few other test cases that we have not validated here, or if you want to find the brute force solution, you can use the link in the description box to go to codingpal.org and check the same thing. Anyway, that's it for this problem. Thanks for watching. I'll see you in the next one.